if you have the equation of the form dy dx plus gx of times y plus hx times y raised to power n is equals to 0, where n is not equals to 1, then what you are dealing with is what we call a Bernoulli equation. Sometimes we can write that equation as dy dx plus p of y is equals q raised to y raised to power n. So we have an example here that we want to solve. We want to solve the equation dy dx plus y over x is equals to x cubed y raised to power 4. So we make a substitution. V is equals to y raised to power 1 minus n. And in this case, because our highest power is 4, then it will be 1 minus 4 is equals to y raised to power minus 3. So our 4 is the greatest power of y that we have in the equation. Y to power 3 is equals to 1 over v. That's I get dv all over dy is equals to minus 3 y raised to power minus 4. And this means that dy dv will be given by y raised to power 4 all over 3. Why am I interested in dy dv? Because I need to rewrite dy dx in terms of dv. Remember, my original equation is dy dx. So dy dx is equals to dy dv times dv dx. And since now I have an idea of what my dv dy is, then I know my dy dv, then it will give me negative y raised to power 4 over 3 times dv dx. Know that dy dx is given by, this part is given by 2x cubed y to power 4 minus y over x. This should be equal to this part, which is the original part, the original problem that you are given, should be equal to negative y raised to power 4 over 3 dv all over dx. Now, the other thing we know about is the value of v that we want to use. So now if we try to make dv dx the subject of the formula, then we have dv dx will be equals to minus 3 y to power 4 of 2x cubed y4 minus y over x. And that reduces to negative 6x cubed plus 3 all over x raised to power y to power 3. But we know that v is equals to y raised to power negative 3. Therefore, y cubed v is equals to 1. And that means y cubed is equals to 1 over v. Or 1 over this is equals to v. So the inverse of this, 1 over y cubed is equals to v. And that's what we want to substitute. And therefore, we have dv over dx is equals to negative 6x cubed plus 3v over x. So we have x dv is equals to negative 6x to power 4 plus 3v dx. In other words, we have x dv plus 6x to power 4 minus 3v dx is equals to 0. And that equation we have there is a form equation where we want to make this component here, this will become my a of xv, and this component will become my b of xv. And what am I interested in? I want to look for the integrating factor. So db all over dx is equals to 1 and is not equals to dA over dv, which is equals to minus 3. They are not equal, and so that will not be the case. Now, for the purpose of making it easier, I can write this as dv plus 6x cubed minus 3 over xv dx is equals to 0. Why did I write that? Because I'm writing my integrating factor as a function of x, and therefore my integrating factor if, which is mu of x, is equals to the exponential, the integral of negative 3 over x dx. That is my integrating factor. Becomes e raised to power minus 3 ln of x, which is e raised to power ln of x to power minus 3, which is x to power minus 3, which is 1 raised to power x cubed. So now I have my integrating factor. I multiply it into my equation. I have x raised to power minus 3 dv plus 6 minus 3v x raised to power minus 4 dx is equals to 0. Therefore, I can write this as 6x minus 3v x raised to power minus 3 divided by minus 3 plus f of v is equals to c1. So that is what we are going to do there. We are integrating the component here. So this is the component that we do the integral for. And when we integrate 6, we get 6x. When we integrate this with respect to x, that is part that we get. And this gives me 6x plus y raised to power minus 3 all over x cubed is equals to c. And that's the solution. How did I get y raised to power minus 3? Remember that v is equals to y minus 3. And in this part here, I'll be left with v as one of the values, and that is the value that I have there. Therefore, that is the solution.